Hello, hello. All right. I think it's about time to start. Okay. So, I think I'll just jump on in and that's what we'll do. So, all right. This is domain modeling in object-oriented and functional programming. And obviously, when I saw the slides today in the morning, I realized, well, that's a pretty long title, right? So probably a little too much. So I'll just shorten it ever so slightly. Domain modeling in OOP and FP based on C# and F#. This is going to be a slight comparison. This is going to be quite a lot of code. And yeah, let's see if you like it. But first of all, well, hello, NDC Oslo. It's an absolute, hey, it's an absolute pleasure to be here. And I'm really, really stoked and just happy. So yeah, let's move on. But first, the shameless plug. Like Marcin Kern. Did you hear the name? Probably not. Who the heck am I? Like, who are we talking about, right? So in my professional experience, I do about 10 years of commercial .NET development, and I went through a lot of different projects, like CRM in Poland, through DNA in Poland and Germany. That's actually quite an interesting experience, I've got to say. And I'm moving towards hearing aid in Denmark, so somewhere close or nearby, should I say. I did different kinds of apps, like even started from a desktop app with DB beside it, right? Did some web development with React, or embedded development also with React, which is kind of weird. And I've been using Azure or however you want to call it, extensively. I'm also a fan of TDD, fan of Agile, but probably not too religious about both of those. So yeah, that's it. In my private life, I do have a 2-year-old son who's absolutely amazing. I've got even more amazing wife. And I do have some hobbies like we all do, so some PC gaming, digital painting, and when I'm just too damn curious, new programming languages. And probably that's where this whole talk is coming from. So yeah, that's cool, fine, but let's get back to the topic. That's why we're here. Okay, domain model. So what I want to talk to you guys about is the why and how of DDD. Obviously, we won't cover the entirety of DDD. That's impossible in an hour, simple as that. So let's first tackle why are we talking about it in the first place. And I've got an example. There's a lot of examples ahead. But imagine an application where you are selling a policy for vehicles, right? So you're kind of an insurance company, you're selling policies. What's interesting there is pretty much the vehicles are divided in two categories, the private vehicles and the fleet vehicles. They obviously are the same vehicle, like underneath, like the model of the car and so on. But in terms of domain language, it's actually a vast difference. What else do we have? We have, in each vehicle, we actually have a black box. And if you don't know what that is, you should be thinking about the black box in an airplane, right? So that's kind of this device that is mounted into the car by a professional mechanic. And the device will track pretty much the speed of the car, the possibility of, or rather, whenever the crash happened, what happened during that time, where the brakes stepped on, and so on. Okay, and this is what is being done in UK. Actually, the black boxes are not optional, but they are just required there. In terms of drivers, we've got similar story. We've got fleet drivers and private drivers. But the main difference here is that the policy in general can be sold for the whole fleet or for a particular driver. And when we are talking about particular driver, we are talking about particular vehicle, right? So the policy is sold for that exact vehicle. So how do we model this in a classical approach, I would call it? Well, my idea is quite simple. We do have a vehicle that has some types, and since there's always this one-to-one relation between vehicle and black box, we can actually treat the black box as part of the vehicle. So we can go that way. So black box parameters are also a part of vehicle here. We've got driver, once again, with two types. We've got policies with the parameter of either the driver or the fleet. And here is something a little bit more complicated because we do have an optional parameter. Because if the policy is sold to a driver, you've got an optional parameter of vehicle. Because as I mentioned, that's the relation here, right? And this is all fine and dandy. So now, let's make a change. And the change is, let's add a new type of vehicle, a short-term rental vehicle, and also what is probably more important, a new type of black box. And this black box is actually movable because this little black box is now handled through putting it into cigarette space, right? So that's how you can move the black box from car to car. So what changed in the domain language itself? Well, we have a new vehicle. Then we have new type of black box, because now the black box can be either sold per vehicle, this permanent black box, or per driver, this one that is movable, right? So the whole idea is that the driver can switch between cars. What else changed? Nothing much here, apart from the fact that private driver now can have the policy bought for the vehicle or for the black box that is movable. So that's the change. In our output, or in our classical way, what we have is, those are the changes in yellow, right? So we do have, first of all, the new type of the vehicle, and now we have to extract the black box. Obviously, we could have done that from the start, but either way, that's a change. Now the black box have types and other parameters and so on. What happened next is the driver has now the optional parameter of black box because, once again, the driver can have the black box attached to it, right? And the policy can be sold either for the vehicle or for the black box or for the whole freaking fleet. So it's nothing wrong with this approach, but imagine we do a few more changes, and those are the projects that I've been working on, like some legacy code, usually. And there's a few more changes happening, and after a while, you no longer understand what's going on. And first of all, well, you have to play the human compiler. If you are talking about somebody from the domain language, you have to just be the compiler, and you have to explain what does it mean for him, or rather understand what does it mean for him, and how it translates to your code, right? And well, after a few more changes, like on top of those changes, the new person joining the team probably won't be able to go from the code to domain language. It's actually opposite for you guys, sorry. So this way around. It's a hard thing to do. It's a hard thing to describe. Obviously, we can solve it by documentation, but, well, who wants to do that? So what's the other alternative? The other alternative is modeling the domain in the code. So whatever you have on the left side, you put on the right side. The code and the domain is pretty much the same. Interesting trivia here. The DB model, since it doesn't translate so easily, it can still be held in a classical way. It just needs to be abstracted a bit, right? So this is exactly what I want to focus on. Why? Because for the future, pretty much. For the future is our answer to why I do domain modeling. So the first point of how to do the domain modeling is domain language and code should be the same thing. And then I don't know about you, but this is exactly what was promised to me by OOP in my study years, right? This is exactly what they meant. Like whatever you have in real life, you just translate that into code, and that all works. Unfortunately, at least in the code I've seen, that's not really the case. Okay, second rule of domain modeling, let's move on. So what I have in here, another example. Imagine a class or an object that has those fields: email, initials, ID, distance in kilometers. Like, I seriously don't know what that object is. It's an example. But the question is, what do you do with validation of that, right? Do you have a separate validator class? Do you have a method that is called validate? Do you have, God forbid, Boolean value validated? Please don't do that. Never. Please. But the questions arise, right? Also, what about the operations? Nobody in their right mind would add email and initials. It doesn't make any sense. But you can do that in the code. It's actually a problem for the long run, in my opinion, obviously. The same thing you can do with ID and distance. It's kind of not what we want. So what do we want? We pretty much want to, well, replace all the basic styles or the basic types, sorry, so we can have control over those. Validation in constructor, obviously excluding the validation that is really expensive. If we have expensive validation, we do it completely differently. But for the simple types, validation in constructor. And operations are getting really simple because email plus initials, that's a compiler error. You won't be able to run that code. And that's exactly what I want. So the rule is disallow incorrect state to be represented in your code in the first place. So, to sum up, two rules that I will focus on today in terms of domain modeling is domain language equals code, and second one is disallow incorrect state to be represented in the code. And let's go to some meaty code there. So, all right, let's model a vehicle in object-oriented programming. As I mentioned, we replace the basic types. So we replace all of it. The vehicle has those 5 fields. And as you can clearly see, those are only getters. So pretty much once we create those, we're all set and done. We're happy. We have to have a completely separate setter if we want one. The whole vehicle then looks like this, like the constructor of the vehicle looks like this. It's quite simple. Oh, it's not showing here, sorry. Oh, here we go, okay. So the constructor for the vehicle is simple. We get those parameters. We just check if they are nulls because they are validated in their own constructors. So we just check nulls and we're happy. We go over. Vehicle make is a special example here because that's just an enum. So it's not a null, right? And I'll show you one of the constructors of those types, just as an example once again. Registration number. All in all, after all, it does have the string inside because we need to represent that somehow. And in code, registration number is a string. And we do have some validation rules. They're quite simple. We do take a look at the length. We do take a look at disallowed characters, and so on. And as always, we have to care about the null here. All right, so what do we get by that? How do we use that vehicle then? Well, usage is, as you can see in the line 4, pretty much, you create a vehicle, you create all of those registration numbers and parameters and everything. And then in line 11, you no longer can replace registration number with null, which is exactly what we want, okay? What else do we get? We cannot add registration number and the model. This is, once again, what we want. So good job, us. And one last thing, and it's still not showing. Okay, I've got to look here, sorry. The last thing is when we run registration number with a little too long text, since I created it that way, it just throws an exception, okay? If that's a good practice or not, that's a whole different discussion. So let's not go there now. And one more thing about object-oriented programming, if you replace all those types with new types, it kind of gets unwieldy. I mean, seriously, it's only a vehicle, and we have already 7 files. It's a little too much for me. But then again, you don't want them all in one file, because that's not the convention. Yeah, it can get messy. All right. So let's go functional finally, right? But stop. Stop for a moment, because yeah, let me just cover some very basic F# things so you can understand the examples. Probably most of you guys know this, but it's only 3 slides. I promise it's going to be quick. So what I want to show you guys is for the F#, we don't have classes, we don't have objects. So what do we have? Similarly, it's still a .NET language, so we have the similar classical simple types like integer, floats, booleans, strings, that's all there, right? But for the complex types, we do have 2 different things. So we have discriminated unions, and think about enums, but on steroids. They are actually better than enums, and I will try to explain why. Second thing is records, and if you're thinking about records from C#, that's exactly what it is, because it's just a class that cannot be changed and is compared by the value rather than reference. One important or interesting part still is type inference, but that's much more easier to explain in the example. Simple types, as I mentioned, nothing special. Treat the let exactly like var in C#. So it's just let test integer equals 1. That's an integer. And actually, the fact that we didn't get the type or set the type in any way is called type inference, but it goes a little farther than simple var in C#. Once again, I will show you that. All right, so now the complex types. Those are the more interesting. So let's go by those points that I mentioned here. So the first point, gender, this is actually the discriminated union, so an enum that I mentioned, right? And when you see the number 2, that's what's interesting about discriminated unions, because you can have the normal male-female, but you can also have the other gender, which is actually a string underneath. So when you create a gender that is other, you have to explain what that really is, what exactly it is, okay? Once again, for male and female, we don't need strings. We just need it for that third option. And that's actually kind of interesting. Okay, third point, and this is how we create records. As I mentioned, those are very much similar to classes and objects. So there's nothing really special in here. The special part is number 4, which is different than C#, because in C# we say list of the type, and here it's reversed, right? It's the type list. Okay, let's go. Now let's go functional, as I promised. So model the vehicle in functional programming. So once again, replacing those basic types, and I usually do replace those basic types by a single discriminated union value. You don't have to care too much about it, but the gist of it is it's string underneath. It's like a wrapper for a string, exactly. But since it's a wrapper, we cannot add them together like 2 different types. We cannot just interchange them, all right? And in terms of vehicle itself, number 9 or line number 9, that's a mouthful, by the way. It's once again a record, which pretty much is just like an object in C#, right? I'm not sure why it's not showing up sometimes, but let's move on. So very similar. I'll show you registration number once again, and I'll show you something that it's not really a constructor, but you can think about it the same way. It's something that allows us to construct the registration number because it was actually marked as private. Why do I do this? Obviously, because I want to have the same validation. So the same validation because I'm checking out two things here in line 23 where we have the match. This is pretty much the same thing as switch from C#. So we are matching for the length of the number, and remember the number is a string. And we're also checking if there are some disallowed character presents. And yeah, we're just checking the length, first line, then we're checking that disallowed characters are present. Nothing too surprising here, the same logic as we had previously. But the very fun part is there is no null check needed because, well, it's functional. You cannot use null. All right, moving on. How do we use that vehicle then? Once again, we're just creating the vehicle. Very similar thing. You just have a little bit less brackets here on the F# side. So this is how you create it. And this is one more thing that we really needed. So we wanted not to be able or disallow adding up registration number and car model, right? We have that here. Success. Here we go. We also cannot change registration number after creating the car because it's functional. So that part we get for free. What else do we have in here? This is strictly not really related to the example. This is something I wanted to throw in because usually we don't throw exceptions in constructors. That's probably not the greatest of ideas. What you could do is return something, return a type that, once again, is a discriminated union of either OK of this record or error with some explanation, so probably a string. And this is a little bit more common practice, so just wanted to put it out in here. Now, let's introduce to our vehicle one more change in the domain space. Because the vehicle now can have an engine that is either gasoline-based or electric-based, or actually a hybrid one. And hybrid one is just those two engines combined. It's usually not combined in a way that it's one engine, but rather a car has two engines that are different from each other. One is gasoline, one is electric. So how do we model that? All right, let's start with object-oriented once again. So how do we do that? How do we approach it? What I thought to do, first of all, is add line 25, list of engines. Because once again, it can be one engine, gasoline or electric, or it can be both of those, right? And it's kind of very easy to follow along that you will create an engine class, and then gasoline engine will inherit from that, electric engine will inherit for that, and the list of engines then makes sense, right? Obviously, you just assign it in a constructor. So let's see some things in here. Since this is a list, once again, number one, we have to check if it's a null. Number two, we have to check still the count, like the length of that list. Because as I mentioned, it can be only one or two. It cannot be empty. It cannot be three. And number three, if the count is exactly two, we have to make sure those are not two electric engines. So we have to compare the types of those somehow. All right, so this is this is how I would use it then. So we create the first engine that is gasoline engine, the second engine that is an electric engine, and then we pass along in the line 18 list of those two engines, right? Once again, we're just really growing in terms of classes here. So just want to mention that up. And we're done, right? Well, not really, because, well, you can quite easily add an engine afterwards. So this approach completely doesn't work, right? Yeah, this is a little bit messed up. So what I thought to myself, well, let's just exchange a list to an array. The array is a set number of items. So if we set 1 item, we're good. If we set 2, we're good. All good, right? Oh, sorry. But then again, arrays can also be modified by set values, so we still can have 2 electric engines. So once again, that's not the right approach. We probably would have to create a new class that is overarching the list of engines and just have it in there, right? Let's go functional then. How do we do it functionally? So the idea is, once again, we create gasoline engine and electric engine. And those two are actually a bit different, obviously. One interesting fact that I found out, which I was not aware of, I'm not a car guy, the coolant is actually completely different in those two engines. So you really should not use the same class of coolant volume in liters for both, because it's a completely different beast. So you probably should create gasoline engine coolant and electric engine coolant. What else is here interesting? Well, we do have some repetition actually, right? Because we do have the horsepower here and there. This is obviously something that would land in a base class, usually in object-oriented programming. And in functional, I would accept that repetition, but that might be just my taste. Let's move on, how to use it. And this is something that I really, really like. So once again, what I wanted to do is either gasoline or electric or both, right? But never two electrics. You can actually represent that as a one union type. You have the gasoline, electric, or hybrid. And hybrid has a subtype of those two, gasoline and electric. So it's actually like described word for word, really. How do we use it? We just, into the vehicle, we just input that exact type of our discriminated union. All right. Now, how does it look in practice? We create first engine, second engine, and then for the car, at the very last line of this code, we've got engine or hybrid, which is, well, we do hybrid, and then we just pass along those two engines. That's exactly what is happening in here. Interesting trivia. I mentioned that type inference mechanism, right? So look at number 1. I never said it's actually a gasoline engine. Never ever have I said that. It's, once again, inferred from the type itself. So as I mentioned, it's like var, but it's a little bit stronger probably. In general, F# is a little stronger types going for it. And once again, in terms of file structure, this is all I've been doing, right? Because those types, those simple types, are so simple, there are one-liners, I can easily keep them in one file. There's nothing wrong with that. So for the engine, I do have some other types in there. And a bonus point, because at this stage of our functional writing or functional modeling, we already can model a behavior. So let's check it out. I'm not showing here OOP because I assume you guys know exactly how to write an interface for a method. So I just wanted to show you the other side of the coin, right? So without writing much implementation, we can create a type of the method that will describe the behavior, right? And let me just explain to you how to read that. So the type of the method is, the method accepts two parameters, vehicle and distance in kilometers, and it spits out another vehicle, so that one last thing after the arrow, that's actually an output from the function, okay? You get in vehicle, you get in distance, you spit out a new vehicle. Can you guess what that is? I hope that wasn't too complicated. It was something of a line of add distance or add travel distance and so on, right? If you are curious how it would look like if you wanted to use it, actually, that's line 59 for you. So you create an add distance traveled function, which is of the type of add distance, and then you go on to create your own function. And once again, line 61, this is just telling you that you are creating a new vehicle based on that previous one. You're just changing the distance traveled. So this is a previous vehicle with distance traveled. Obviously, once again, it's functional programming, so it's actually a new record at the end. So just wanted to point that out and stress that out. All right, and here comes the F# selling point for me personally. Let me just show it to you. What we have in here is the whole type structure of the vehicle, right? And even included the behavior of the vehicle. Obviously, it's only one example, but you do have the behavior in here. And I would argue that once you explain those arrows, you easily can show it to your subject matter expert. This slide, you can show it to him and you can discuss it with him, because he might mention, all right, cool, but we probably don't measure distance in kilometers, we do it a little bit differently, and so on and so on. It's already something that you can talk to with a person that doesn't code. And I really think that's absolutely bonkers beautiful. All right. If I have sparked your imagination, and if I've managed to, well, get you curious about F#, I do have one beautiful recommendation, and that recommendation is the name, actually the person, Scott Vlashin. He's amazing. He's a legend in F# community. He's really, really great at explaining things. He does that so well, I'm completely jealous. And what he created is a website that is called F# for Fun and Profit. It's a whole website where you've got pretty much everything F# explained, from the very start to advanced techniques. So that is an easy recommendation. Just a note, for some time, I don't know why, but the first link just didn't work. So it's also published in Gitbooks. If you want to check it out, it's fully free. You should be, I encourage you to check it out if you want. He also published a pretty cool book called, I think it was Functional, Domain Modeling Made Functional. It's really awesome read. I do recommend that quite heavily. If you want to stay in touch with me, I'm more than happy to do so. So if I usually use LinkedIn the most, so if you want to jump in and just pick my brain and talk about stuff here and there, don't hesitate to add me. If you can, just mention NDC to me, so I know where you're coming from. So that would be absolutely lovely. But I'm still here. I'm staying for the today and tomorrow, the whole day. So if you want to approach me and just grab a cup of coffee and just talk, I'm more than happy to do so. Instagram, if you're interested, I'm using it a little, not so much. Probably LinkedIn is a better bet. And actually, I think that's about it from me. So do I see any questions, guys? Is there anything? Oh, yeah. OK, now I can see. Is there any questions you guys might have? Shoot.
With this object inference, if there's sometimes that the compiler will get it wrong and create you wrong.
Cool question, thank you. So the question is about type inference, right? Is there a possibility that the type inference will get it wrong? Yeah, absolutely. Absolutely it is. And the easy thing is you can always specify the type. So if you have the same type, or rather the type that is pretty much looking the same as the other one, you can always specify that here in this variable you want to use that second type, right? So that's actually quite simple and quite nice. Thank you. Anything else, guys? All right. Then, once again, I'm here. Thank you very much, guys, for attending. And as always, we can do better as a pack. Thank you.